In last video, we discussed about scalability and what is scaling vertically and scaling horizontally. Apart from that, we discussed about various data processing models and load distribution. The last topic we discussed was distributed processing. We have discussed what is distributed processing and how to implement distributed processing. So the implementation part, I want to explore a bit more. So if we have to know how we can implement distributed processing, we can just say offline batch jobs that can be horizontally scaled by using a distributed data processing engine like Apache Hadoop. So that can be done using this something like distributed data processing engine, like as I said, Apache Hadoop. So on AWS, you can use the Amazon Elastic MapReduce, Amazon EMR service to run Hadoop workloads on top of a fleet of EC2 instances and without the operational complexity. For real-time processing of streaming data, Amazon Kinesis partitions data in multiple shards that can then be consumed by multiple Amazon EC2 or AWS Lambda resources to achieve scalability. So these are the part of data analytics. So that when you will use these services, you will be able to know about how we can scale data in and resources in analytics using AWS resources. So now moving on to the next topic, that is high availability. So high availability is making your production environment available all the time. So if there is some failure happening or something goes going wrong, user should not be affected. They should not be knowing that this has happened in the backend. So this is what high availability is will try to achieve. So to do that, you can just create environment where you can distribute your loads on multiple, and in that case you can use elastic load balancer that are the excellent example for providing high availability. And for region level high availability, you can use DNS round robin using Amazon Route 53. So that also provides the same capability. And you can just add a bit more features like auto scaling in elastic load balancing. So it will complete the fleet of EC2 resources. If there is some issue with few of the nodes, it will just roll up new instances and it will maintain the desired capacity that is required for elastic load balancing. So that is I think that covers the high availability of infrastructure. Now moving on to disposable resources instead of fixed service infrastructure as a code. So in a traditional infrastructure environment, you have to work with fixed resources due to upfront cost and lead time of introducing new hardware. So this would drive practices like manually logging into the servers to configure softwares or fix issues, hard coding IP addresses, running tests, or processing jobs sequentially, etc. So when designing for AWS, you have the opportunity to reset that mindset so that you take advantage of the dynamically provisioned nature of cloud computing. You can think of servers and other components as temporary resources. You can launch as many as you need and use them only for as long as you need them. So another issue with fixed long running servers is that the configuration drift. So changes and software patches applied through the time can result in untested and heterogeneous configurations across different environments. So this problem can be solved with the immutable infrastructure pattern. With this approach, a server once launched is never updated throughout its lifetime. Instead, when there is a problem or a need for an update, the server is replaced with a new one that has the latest configuration. So in this way, resources are always in a consistent and tested state, and rollbacks become easier to perform. Instant Instantiating compute resources. So when you are deploying a new environment for testing or increasing capacity of an existing system to cope with extra load, you will not want to manually set up new resources with their configuration and code. It is important that you make this an automated and repeatable process that avoids long lead times and is not prone to human error. So there are few approaches on how to achieve an automated and repeatable process. The one is bootstrapping. So when you launch a AWS resource like a Amazon EC2 instance or Amazon Relational Database DB instance, you start with a default configuration. You can then execute automated bootstrapping actions, that is scripts that install software or copy data to bring that resource to a particular state. You can parameterize configuration details that vary between different environments, for example, production, test, etc., so that the same scripts can be reused without modifications. Now, how you can implement bootstrapping in practice? So you can use data scripts with cloud directives or AWS OpsWorks lifecycle events to automatically set up new EC2 instances. You can use simple scripts, configuration management tools like Chef or Puppet, and AWS OpsWorks natively supports Chef recipes or Bash PowerShell scripts. In addition, through custom scripts and the AWS APIs, or through the use of AWS CloudFormation support for AWS Lambda-backed custom resources, it is possible to write provisioning logic that act on almost any AWS resource. Now, there is a concept called golden images. So, certain AWS resource types like Amazon EC2 instances, Amazon RDS DB instances, Amazon Elastic Block Storage, volumes, etc., can be launched from a golden image. And a golden image can be a snapshot of a particular state of the resource. So when compared to the bootstrapping approach, a golden image results in faster start times and removes dependencies to configuration services on third-party repository. This is important in auto-scale environments where you want to be able to quickly and reliably launch additional resources as a response to demand challenges.